Yeah, today we're going to talk about Speckle for visualizations and simulations in urban design. It will be myself and Alan. Um, just to briefly give introduction, I am urban planner by education, and I worked previously in research area and currently joined Speckle as an intern to work on the front end development. And we have also Alan.
Everyone, my name is Rynne. I'm a software engineer at Speckle. I've been here already for a year, which seemed to have passed very fast. And my background is in building engineering, and I did a master's in parametric design, and I've worked at several lesser-known companies in Spain before joining Speckle. I also teach at IAC and UPC in 2 different masters related to visual programming and programming in architecture in general.
Okay, thank you, Alan. So as you can see from the brief description, we're going to talk about building a story with spatial data. And the problem statement we would like to address here is lots and lots of data accompanying our design projects. And when we need to communicate and share this data and the other person have to build decisions upon the data we shared, it becomes very complex. And not only it's important what data we share, the most important is what data the other person receives and what conclusions and interpretation they make from it. So the way we share data is not less important as the data itself. And to do that, we need, of course, a proper exploration interface to do so. Today, we're going to focus on the spatial data, especially the one that can be represented as a geometry. It can range from a very simple design sketches, form findings, to a complex simulations that needs a standalone software to run it. Why also this I find this particularly relevant for urban planning is because for urban large-scale projects, in particular, especially in the conceptual phases, it becomes very important to be able not only communicate technical data, but also to explain your concept, explain your vision, explain your design intent, and explain why probably you would like to deviate from some of the design brief. So you have to make a lot of points supported sometimes by data. And what we're going to do today is we're going to briefly remind you about Speckle infrastructure, show what parts of it we're going to use to help with the storytelling part, show some features that can be developed, and in the end, we're going to run a fake or mock presentation of some hypothetical. So you're probably familiar with the Speckle idea in general. The main part of it is a data schema that lets you import and export the design models from and to different apps. This could be design apps like Rynne, Revit, Grasshopper. It can be non-design apps like Excel, or it can be a web app developed by Speckle for exploring your streams and your models. So today we're going to talk about Grasshopper connector, which has more extended functionalities than other connectors, and the web viewer in particular. So probably you are already familiar with the web viewer that Speckle provides. It has the very basic functions. You can scroll around, zoom, explore your model. You can select the named views from Rhino, or you can choose the default views. You can zoom in your model, you can make sections, or you can go full screen. So basically everything you need to make a simple model exploration. What I want to talk about today is extended functionality, which can be easily built on the existing one. So there will be 4 parts. One is the layers of data that we can query. The other one is switching between the views, and the other one is combining all of them. So I'm gonna go a little bit more details in each of them. So the first, I don't know if you can see the title because in my screen it is covered by the name of the talk, but basically it says layers filter by property. So the button, which I call layers, is what allows you to call a specific property assigned to the object. For example, in this model, I created several objects. Some of them I added the property called daylight, which was generated freshly from Ladybug, where you can see the hours of sunlight on each, let's say, pixel or whatever resolution you set in the settings. Or you can go to another layer called isovist, which calls the object which has a property isovist to see what areas or which shop fronts are visible from a particular point of view. The other function added was switching between different views. So you already know that we can switch between the views manually, top, front, back, and other default views, or the ones we created in Rhino, like 0, 2, 3, 4, right here. But what would be more convenient is to be able to switch between them like the presentation slides sequentially. So with these buttons, which are extremely easy to implement, we just go through views one by one, flying from one point of view to another for a very smooth flow of presentation. The other function, which was not present in the first panel, is the coolest one, is the animation. So in this case, we extended the object instead of just assigning one property, which is called animation. We created multiple objects with a property animation, but added numerical value to each of them. And this numerical value in this case corresponds to the hour during the day. So we can use a slider to call this number and call the object that has this numerical property. We can use a slider visually, we can remove the slider and just call the objects one by one with some time interval, which would run the animation by itself. And the last function is basically combining all of the previous functionalities. In this case, I would call it this switching between the slides because it lets you switch between different points like you do in a PowerPoint. Instead of just switching between the views, it lets you attach specific filters to each view. So by calling a view from the top, for example, you would visualize one of the layers. By calling the next view, you would call the visualization of the other layers. So I'm gonna show how it works here. So I created a sequence of the views. I imported them from Rhino, and for the first view, I assigned the animation of the shadows. For the next view, also shadows. For the next view, the isovist, and so on. Except only visualizing the layers and their properties, you can add any more features to each view. You can display the text, you can display other things, which I will show later in this mock presentation. So how is this implemented in Grasshopper? To create the basic object, for example, the shadows. Okay, it's not so basic, it's a complex object. I used a very basic Grasshopper component, which allows you to record every iteration. And while running the simulation, I'm recording the data in two separate lists. So the first list records the geometry, every iteration of geometry, and the second list records every iteration of numerical value assigned to this geometry. And then I export it to one of the branches. And finally, when I have all the objects created separately, I have this interface or Grasshopper file where I basically combine animation. I'm not dealing with any geometry anymore. I'm just combining the animation from all the data that's already available. So the first step here, we can call all the data streams or data branches that we have created with different data layers. These data layers can be created either in Grasshopper or in Rhino, in any software that you need for it. And then the latest version of it from each branch can be received in this interface. Later, when we received every of the data objects, we can extend this object by adding the extra property. The extra property is very easy to be human readable because you need to call it later. So in this case, I assigned to the model object no properties. To the second object, which is isovist, I assigned property isovist. To the sunlight, property sunlight, and so on. And aside from the objects, I also called the Rhino named views. And for each of the views, I assigned filter on which objects I would like to call in each view. In the first view, I would like to call the animation. In the second view, nothing. Then isovist, and then the sunlight. And having these two grasshopper speckle objects, I can just put them in the one combined object and send it to the main branch. What is important to remember here is that you're basically inventing the structure of the objects by yourself. You have the custom names that you are creating. You might also have custom different structure than the one I'm displaying right here. So it is important that when you are making filters and adapting the front end part or the viewer, you have to remember what structure you created and you have to adjust it accordingly. So this is how the desktop might look like, or how it looked like when I was creating the presentation. I have one of the softwares, for example, Rhino. I'm creating the data layer here, for example, the named views. I have a Speckle connector. I'm sending the data to the stream presentation to the branch named views. And I set the filter of the views only because I don't need to send any of the objects. I only need the views. I send it. Then I go to my Grasshopper file. I received here the latest version of whatever I have sent before. And this can be done from any other software. And we have some good news for you, which is
that we are preparing a new connector. If you've been following our forum posts, maybe you've already been aware of this, but we're currently in a very alpha release of a QGIS connector that would allow you to extract data from QGIS layers and bring them to Speckle to consume the same way Kateryna just did with the cameras in any other software that we connect to. This is specifically useful right now in visual programming environments, mainly because they allow you the flexibility to kind of do whatever you want with the data. But we are really looking, can you go to the next slide, please? There you go. So we're really looking for people that are willing to test it and excited about QGIS and Speckle working together. And we would really appreciate your feedback. Right now, the functionality is quite limited to extracting point line polygon-based layers and all of the features and metadata attached to them. And obviously sending multiple layers at once into a stream, not only sending like the entire project, but you can actually select which layers of your QGIS project you want to send. And sadly, there's no automatic installation of this. So you will have to go to our QGIS repo, which is in the next slide, Kateryna. There you go. I think Dimitri already posted the link to the QGIS connector page. So if you go there, you will find all the information that you need. So feel free to reach out if you're interested. We'll be happy to help you out getting it set up and receive any feedback, positive or negative, about it. And so, yeah, I'm hoping to see you around our community if you're a QGIS expert.
Yeah, it sounds very promising. I've been looking forward myself. And now I think I'm gonna try a very risky thing. I'm gonna attempt a live demo of the mock presentation. So here is the front end, the same as you can find on the Speckle official server. I have my stream called presentation. I have multiple branches. Each of them correspond for the type of data I was creating. And here I have the viewer. I already uploaded the data. So I'm gonna go full screen and I'm gonna start the presentation. So we are looking at a small site, a small development site of the city of Graz in Austria, with a little development site, which we have to fit our building in this specific envelope, which follows current regulations. The form finding process can be different. We went for the creating of the rooms, so like a Lego blocks style, assigning different functions and playing with the geometry around it. Then you can look closer into the structure of this building. We would also like to highlight that the microclimate in each of the floor will be very suitable. There is enough sunlight. The simulation here shows the universal thermal comfort index. We also can guarantee that you have a perfect view from each floor, from the third floor, and from the high floor as well. Then you can see that the facade is made with all the latest technologies, with all the perfect materials. If we go further away, we can also see that the building is really well accessible, well integrated into the city structure, and we can access a lot of location within 5 minutes walking. For example, we can access several grocery stores and around 5 cafeterias. And yeah, at any point of this presentation, you might deviate from showing your slides and just use the viewer as normal. So you can go around, you can show whatever point you need to make, and whenever you feel like it, you can go back and continue your presentation. All right. So another feature that had not been mentioned before, except for showing or changing the visibility of the layers in each slide, you can also make extra actions. For example, here I made a small panel where I displayed, for example, the name of the layers that I'm calling in each view. You can post the custom text here, custom explanation. It would be really helpful if, for example, you're not making presentation live, but as you know, the viewer, the 3D viewer, can be embedded on the web page, and you can leave it there for people to watch themselves. And when they go through the presentation, they can read the description and understand better what you want to tell with a specific slide. Again, any other functionality standard for the viewer can be applied here, like the section and so on. And yeah, the layers can be switched. And yeah, going back to the main point, the main point I would like to make is that with all the infrastructure and interoperability that Speckle provides, that lets you put all your data into one system and one model, it becomes very easy to use these little features to build the story about your model and about your data without creating any additional visualizations, additional Illustrator images, and so on. And I feel like this part of functionality is being a little bit overlooked in Speckle, and I think there is huge potential with all the data and data infrastructure it provides. So we've been a little bit early.
We have some questions though.
Okay.
There's an anonymous question in the Q&A. How much did you have to hack around the Speckle's viewers' current limitations? So how much is this skipping over our implementation on versus preparing the data carefully, which I think is kind of a bit of both, but I'll let you tell the story.
Shall I stop the screen sharing so I can also take a look at the messages?
Yeah,
okay, actually I can do it here. Okay, so how much how much did it take to hack around Speckle? Okay, so I will go one by one. These little functions here, the easiest one is switching between the views. So right now, Speckle viewer is receiving each of these named views you sent, for example, from Rhino, and it already has them prepared as a list. So basically, all you need to do is to assign a function iterate +1 whenever you click this button, or -1 when you click previous button. This was the easiest one. The layering part is not as problematic as well, because whenever you load all the objects, in my case, I separated the objects from the entire pool of objects into separate groups of objects. So I had a separate group for animation object, separate group from visualization object, and that made it easier to call them later. For the animation, it was the same process. From the group of animation objects, I was calling them one by one by the numerical property, and then resetting the slider every time. So it took some time, because that's not exactly made. That was not made before, so that was first attempt. It took a lot of trials and errors, but I think it can be fairly easily implemented.
Cool. We have another question. Shannon Pendleton. How long have you been using Speckle, and what path do you recommend building science experts follow to start working with these tools?
What path do you recommend? All right. Okay, so it all depends on what interface you're using for Speckle. In my case, I was using the Rhino and Grasshopper interface, and I'm using Grasshopper as my own hands, so it was fairly easy for me. Although there are some specific features which I was not aware of. For example, the connectors allow you to receive the geometry from the stream as a geometry or as a Speckle object. Some little tricks like this. But I think the way to start is you try, you fail, and you ask a question on the forum, and then we help.
Awesome. There's another one from Theodoros Gananos in the chat. Is it possible to do data processing and visualization within Speckle once data is uploaded? I think I got this one. Currently, no. In Speckle, the data that you send is immutable, but you can connect to other services using webhooks and have those services push data to Speckle with the proper analysis, data processing, visualization, colors, etc. Right now, this is not something that we contemplate on doing in the near future. We'll see if we start the processing road somewhere down the line.
Somebody recognized the model. That's the free Revit model that can be downloaded. It took some time to research where is it located and get some more of the location context. So now I'm very familiar with this project.
Awesome. I think we don't have any more questions, but feel free to throw in anybody, our Speckle team that may be lurking on the background, may have more technical questions for us. If not, it's been great having you. I hope you all enjoyed Kateryna's work in hacking through the Speckle frontend and the Speckle ecosystem. And yeah, see you in the next session.
Thank you, everybody, for coming.
See you. Bye.